Welcome back to episode 5 of our data structures subseries. So we're going to look at the last type of array known as the multi-dimensional array. You can also think of it as a matrix. So anyways, this is just an array that has more than one dimension, and a dimension is pretty much just an axis. So in math class we've graphed stuff. So you've probably seen the coordinate system. So we have a two-dimensional coordinate system within a horizontal axis and a vertical axis, usually denoted as x and y respectively. And then you may have seen a z-axis or z-axis defining the actual depth and making it a three-dimensional coordinate system. We can do the same thing with arrays. So we've seen the one-dimensional array. This is not a multi-dimensional array because it only has one dimension, and you can think of this as simply having one axis. So it has like a horizontal axis. Anyways, the most simple type of multi-dimensional array is having two dimensions. So this one has 3 columns, and then it has 2 rows. So it has a horizontal axis and a vertical axis. And then the three-dimensional arrays have 3 dimensions. It has a horizontal axis, a vertical axis, and it even has a z-axis, so a depth to it. So this is basically creating a rectangular prism. Obviously, when we're using multi-dimensional arrays, is not creating a cube or whatever. It's just using different indices and using them relative to each other to specify different positions within that data structure. Anyways, we can access a certain position here, and you can see I've already done it. So we can do this by specifying which row we want, which column we want, and which basically we're specifying for each dimension which index we want to go to. So for the rows, we want to go to row 1. For the columns, we want to go to row 3. And then for the depth, for the z-axis or z dimension, we want to go to the first index. So that would fill in this block right here. So anyways, you can have as many dimensions as you want. You can create 4-dimensional arrays, 5-dimension arrays, all the way to n-dimension arrays, where n is just a number. And it's hard to visualize I think it's impossible to visualize the 4-dimensional arrays or a 4-dimensional coordinate system on a 2-dimensional plane like this screen. So I'm not even going to attempt that. Maybe it is, I don't know. Let's look at the code. Okay, so what we have here is a simple 2-dimensional array, and how we actually declare this is really similar to the 1-dimensional array. We just put as many square brackets as we have dimensions. So we have 2 square brackets, so this is a 2-dimensional array. Now you can see we're specifying the different however many indices we want for each dimension, and how this is set up is the first square bracket is the rows, and then the second square bracket is the columns. So we have 5 rows, and then we have 3 columns. This is a little weird, simply because the one-dimensional arrays, if we create a one-dimensional array and we pass in a size, this is defining how many columns there are. Well, that's how we visualize it, at least. I mean, I guess you could think about it as rows. Oops, that's not what I wanted. You could think about it as rows like this, but usually how we think about it is like that. So it's a little weird how it's set up as rows and columns. So just keep that in mind, that it's rows and columns and not columns then rows. So anyways, we can initialize this 2-dimensional array one of 2 ways. We can do it this way, which I think is the easier way, but you have to know the values ahead of time. So we're just wrapping everything in one curly brace, and then for each sub curly brace that we have, that's indicating a new row. So this is our first row, this is our second row, and so on and so forth. Then within those sub curly braces, we're defining each column, the value at that position. So you can see here we have 0, 1, 2, then on the next row 5, 4, 3, and so on and so forth. So anyways, this matrix is looking something like this, and then with these nested for loops here, all we're doing is printing out each value. So we have a for loop for the rows, and then we have a for loop for the columns, and what that is doing is it's going through each row one by one, and then each time it hits a new row, it's just going through each column. So column 1, column 2, column 3, and then we're just printing out that position's value using those indices. And then for each row, we're just printing out a new line. So anyways, if we save this, and let's go ahead and run it. So I've already compiled this stuff, so we'll just run it. So there you go. We have 0, 1, 2, 5, 4, 3, so on and so forth. And there you can see all those values. So that's an introduction to multi-dimensional arrays. Again, you can go as many dimensions as you want, but it's going to get more confusing with the more dimensions that you add on to your multi-dimensional arrays. Okay, one tip to actually be able to visualize this is you can put these actual sub arrays on different lines so it looks orderly and like an actual matrix. So you can do it like this and then like that, and just do this for each sub curly brace that you have. And now you can see it actually looks like a matrix. So instead of thinking about multidimensional arrays in terms of axes and rows and columns and trying to put a shape to it, instead we can think about it like this. We can think about it as like arrays within arrays. So this makes it a little easier when we're thinking about multi-dimensional arrays that use more than 3 dimensions, because we can't really draw a shape for that. So it's really just arrays within arrays. So you can see here's our outer array, and then within that array we have 2 sub-arrays. So we have a 0 index and a 1 index. Then within each one of those arrays we have 2 more sub-index or sub-arrays. So we have 0 and 1 for each one of those. And then within those we have different positions, so 0, 1, and 2. So in this way we can actually choose which position. So let's say we choose 0 and then we choose 1 and then 2. So we'd be in this position within the overarching matrix. So that's just a little easier way to think about multidimensional arrays.